Hello students, I today discuss about partial differential equation and their methods to solve to evaluate the partial differential equations complementary function and particular integrals. So we need to some ways how to uh, evaluate the complementary functions and particular integrals with conditions given. Then we can very easily calculate comparative functions and particular integrals. So let's start. What is the given conditions and how the procedure we follow that we can easily calculate comparative functions and particular integrals. So let's start. For linear and non-linear PDE, for linear and non-linear PDE partial differential equation. The first way is that Lagrange method. Lagrange method. So first describe what the Lagrange method. If we given a quasi-linear, quasi-linear quasi-linear partial differential equation with the form that capital P and small p plus capital Q and small q. Small p and small q are the partial differentiation of Z equal to R, where P is small p is del Z, partial differential of Z with respect to X, and small q is the partial differential equation of Z with respect to Y. And all PQR is a function of capital P, capital Q, and capital R is a function of XYZ, function of XYZ, XYZ. There are two independent variables X and Y and one independent variable Z. Then we can find out its general solution. general solution it would be I u v is equal to 0. And we have to find out through a condition We have to find out through a condition given, and this is called Lagrangian equation, auxiliary equation. This is a auxiliary equation, Lagrangian auxiliary equation, which is dx by p dy by q and dz by r. By solving these differentials, we will get two solutions of u in the terms of xyz, xyz with a integrating factor c1 and other solution v xyz in terms of xyz. Two relations and of xyz under two integrating factors c1 and c2, and if we put here the values I, u, v, then we will get the general solution of such kind of quasi-linear partial differential equation, which is the form of P P Q Q equal to R. So this is the Lagrangian equation. If you are given a quasi-linear partial differential equation. Chart fits of the auxiliary equation I have already discussed. Chart fits of the auxiliary equation I have already discussed in the video. So watch this video and you will find out the way how to use chart fits method to solve chart fits equation to solve partial differential equations. So watch the video. And the third, this is second, and the third is that if given canonical form of the PDE, canonical form called partial differential equation in this way. Given that this is second order, this will be second order, partial differential equation. Canonical form is that plus any first order partial differential equation. This is first order partial differential equation of two independent variables x1 p, and the partial differential equation of p with respect to x, and q is the partial differential equation with respect of u with respect to y is equal to 0. P, Q, R are the functions of x and y, functions of x and y, and it's have a continuous derivatives, in this continuous derivatives exists. Then the PD, the PD will, the partial differential equation is called there are given PQR of the function Q square minus 4PR if this condition satisfied less than 0, then it will be elliptic. The PD will be elliptic. It will be elliptic. This is the first condition. If satisfied, the second condition, if Q square minus 4PR greater than 0, then it will be hyperbolic. PD will be hyperbolic. And if at last it will be Q square minus 4PR is equal to 0, then it will be called parabolic. So based on the conditions, we have to treat the partial differential equation elliptic, it will be hyperbolic, or it will be parabolic. Now some working rules we will study to calculate the PD. If we will now first calculate the complementary functions of the uh, homogeneous linear homogeneous PD with constant coefficient. So linear homogeneous PD, linear homogeneous PD. How it can be calculated? We have to take that if the partial differential equation is given in this way, f, d, and d prime, with two differentials, differentials with respect d is the d is del by del x, and d prime is that del by del y in this way. So if it is given in this way, then then we first factorize it. We will first factorize it. And we will get in this form. We will get the form BD minus AD prime. What's this? AD says. In this form, after factorization, then we will first calculate in this way if the if it is a non-repeated means if you will put here n after factorization it will we are getting in this form. Then if m is equal to 1 and m is non-repeated non-repeated means just occurring at once after factorization, then the solution complementary function will be I by plus e, and if it is repeated, m is repeated, if m is repeated, then depending on the repetition of the factors, we find out the complementary function in this way. Complementary function in this way. This will be equal to I by plus a, and this term will continue with just taking the repeated and continuous x indexes, first x1 and ey plus ax up to a minus 1 indices of x plus x square by ey plus ax, and this way it will continue depending on the value of m. M this will be at last term x to the power minus 1 by by minus a. So these two conditions can happen to find out the complementary function. So you will have to remember these two conditions, and then you can very easily calculate the complementary function of linear homogeneous partial differential equations. Now we will study another working rule. Now we will find out particle integrals. Particle integrals of same linear homogeneous PDE. So here first condition is that we will use the particle integrals as I have calculated the ways of very function. Particle integrals for linear homogeneous PDEs. We have to take that if AB not equal to 0. If this happens, and if D what is the operator D I have already said, and D prime what is the operator D prime and D place is a homogeneous function of degree n, is homogeneous homogeneous of degree n, degree n, then the particle integral will be 1 by f d slash, and here will be pi ax plus b1. So it can be further reduced in this way: 1 by f pi ab. Here it is already taken that it is not equal to 0, so we can replace this, and we will find out integrals up to n times, dot 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 n times integration. There will be pi v dv up to n times. So here v is taken, v is equal to ax plus by. So the second condition we will now discuss. Second condition, it may be for linear homogeneous equation, that the FAB in the first condition it is taken not equal to 0. It may be equal to 0. In this case, we will operate in another way. How? Then the particular integrals can be found out in this way. We will factorize FD and D slash, and we will get this from D after factorization FD D slash AD slash, and the M may be repeated or non-repeated, maybe doesn't matter, and I X plus B B1. This is on the right hand side. Then we easily calculate this. You will have to remember x to the power n b to the power n by n factorial into n factorial pi ax plus b. Here integrals will be this way. So in the factorization of f d and d prime is necessary to calculate if the FAB, if you found that is equal to 0. Just not no more conditions are just some conditions are left. So it may be that I have already discussed complement functions of particular integrals of homogeneous linear equations of homogeneous linear partial differential equation. If it is non-linear, non-linear, non-homogeneous linear, non-homogeneous linear partial equation, non-homogeneous. I hope that you will know what is a homogeneous. If you don't know what is homogeneous, then you go to your book. You can very easily understand. And linearity. I hope that these are clear to all of you. That's why I am going to discuss it. That what is homogeneous, non-homogeneous, what is linearity. It is clear to you. Non-homogeneous linear PDE. If we again we will start the working group, find out complementary functions and particular integrals. So for complementary function, to find out complementary function, we have to remember that if you factorize this f d, then since it is a non-homogeneous, so after factorization you will get in this way bd minus ed slash minus c. After factorization you will get in this way the form. So now I am here putting m again, and if m is equal to 1, if m is equal to 1 and not non-repeated, non-repeated non-repeated means this the factors will not repeat just more than one times, does not repeat more than one times, then the complement function can be written. This would be cx by pi by plus x by plus x. Since in the power of the exponential we are getting, and the denominator b, so b you have to assume that b not equal to 0, otherwise you will get an infinite solution. So b necessarily not equal to 0. Second condition, it may be that m can be repeated. M can be repeated. M is repeated. The factors are occurring more than one times. What will be the complementary function? The complementary function will be again will be e to the power cx by b, and in second bracket I b y plus ax plus I sorry, there will be also ax, this is ax, and x index of power is 1 by by plus ax, and in this way it will continue, plus the last element we will get pi x m minus 1, because m number of times a factor is repeated. For this factor it will be taken up to m minus 1 terms. How? plus EX. So two conditions are necessary to be remembered to solve non-homogeneous linear equations. And how the particular integrals of non-homogeneous linear equation can be calculated. The particular integrals can be calculated in this way. There are some rules you have to remember. First rule: if fxy fxy, I already said what is fxy. Is equal to e ex plus by. Now the actually for non-homogeneous सर्दी जल माथा में तो सब आराम कर देते हैं कैसे करें Since I have already said that actually the form of a partial differential equation it may be in this way. Get is equal to fxy. So here the for this function particular integrals is to be calculated or evaluated. So if fxy in this form, then and one more condition that if eb not equal to 0, where if d and d as this is factorized in this way, uh, b d minus a d minus c, which is non-homogeneous. So here b and a, and if you put here, if it is not equal to 0, then the particular integral will be integral will be 1 by f. Since it is not equal to 0, you can take it in denominator ax plus b. Second one is that if fxy is sin ax plus by sin ax by or cos x plus by, then particular integrator will be there. Some calculation we will have to do also. After knowing this rule, this is 1 by f t this is sine or cos if ax plus b or cos function of ax plus b. So you have to calculate in this way this term by d square is equal to minus a square this square square is equal to minus b square and d series by putting minus ab, and you have to remember that it cannot be equal to 0 after replacing this. It cannot be equal to 0 stuff after replacement of this cannot be equal to 0. Then you can find out this particular in this case. Third one is that if xy is xm then particular integers we will get in this way. It will be 1 by a d series xm. So here you will have to calculate in another way. Here you will have to first take it in negative of power in this way and factorize and transform it in one of the d or d space one of the form, and then so if you have to factorize it and then take the inverse of minus 1 using binomial theorem you will have to follow. So when you will go through an example you can very easily understand how it can be solved. If you take after factorizing it, if you take this negative minus 1 in the power, then you will get now in the form of d, just one form. There are two differences, d and d prime. So you will have to one to replace the other and then go through the operation doing the derivatives of x or y. Then you can calculate it. So I will give you example later to clear how this procedure can be followed. And the last one, if it may be that there is a function with exponential function, and here is a function b with exponential function ax plus by. Then what will we do? B is a function of xy. B is a function of xy. Then what we will do to calculate the particle integral? In this way, it can be solved. Particle integral. If you wish to calculate, I am writing first the form fd this and v to the power ax plus by. Very easily solved in this way. You have to bring out ax plus by plus by, and then you have to take you have to replace fdd slash in this way. You have to replace d plus a and d slash plus b. So from where you will get a and b? This is a question. From where you will get d, a and b? So you will go to factorize it. After factorization, for non-homogeneous equation, you will get in this form b uh, d minus a d slash minus c in this way. So here after factorization you will get b and a. Put in this way d plus a and d slash b and find out the particular integrals. I hope you like this video. If you like, then subscribe this channel and share it with your friends. And if you have any suggestion, then send me, comment me, subscribe. Thanks for watching. Have a good day.